From the dawn of human civilization, our ancestors have gazed at the stars, seeking to understand the mysteries of the universe. Today we stand on the shoulders of these early pioneers as we venture into the cosmos. Welcome to our exploration of how ancient technological discoveries continue to shape the present and future of space exploration. Ancient civilizations like the Babylonians, Egyptians, and Mayans were among the first to develop sophisticated systems of astronomy and celestial navigation. They meticulously charted the stars, predicted celestial events, and constructed monumental observatories aligned with celestial bodies. These early astronomical observations laid the groundwork for modern astrometry and trajectory calculations, which are essential for navigating spacecraft through the vastness of space. Ancient Egyptians and Indians developed foundational principles in these fields that continue to influence modern technology. Mathematics and geometry are the universal languages of science and engineering.
Let's talk about fractal math and the complexity of African architecture and urban design. So when Europeans first came to Africa, they didn't understand the layout of the towns and villages. They thus thought that the urban design was primitive and very disorganized. It turns out that Africans were using a form of geometry that Europeans hadn't discovered until that point. Namely, they were using fractal geometry. Africans had been using this form of geometry for hundreds of years. Europeans didn't even know that fractals really existed until 1872. If you don't know what fractals are beautiful geometric patterns. They can be very complicated, but at a basic level, a fractal is any shape that looks the same in smaller sections as it does in the largest section as a whole. For example, in this fern leaf, the entire branch looks a lot like one leaf, looks a lot like one section of a leaf. The same thing can be said for the village of Baila, where one house looks exactly like one family compound, looks exactly like the village as a whole. Most African towns and villages have adopted a more Eurocentric, grid-like pattern of urban design after colonialism, but now the West is now trying to turn back to fractal design because it's been proving that looking at fractals reduces stress and leads to better well-being in humans. And it's also been shown that the grid-like urban design of most Western societies actually increases stress for the average human.
These principles are crucial for spacecraft design, orbital mechanics, and the analysis of celestial bodies, enabling precise mission planning and execution. The engineering and architectural feats of ancient civilizations demonstrate an early mastery of materials and structural design. The Egyptians, Sumerians, as well as the later Romans, in particular, were renowned for their engineering prowess, constructing durable roads, aqueducts, and monumental buildings. Modern aerospace engineering draws on these principles, ensuring the structural integrity and durability of spacecraft, habitats, and launch facilities in the harsh environment of space. Advancements in metallurgy, such as the creation of bronze and iron, revolutionized ancient societies. These early metallurgical techniques laid the foundation for modern material science. Understanding and improving materials for spacecraft and equipment durability in extreme space environments is critical for the success of space missions. Precise timekeeping and calendar systems were essential for ancient agricultural and ceremonial purposes. Civilizations like the Egyptians and Mayans developed intricate calendars and timekeeping devices. Accurate timekeeping is vital for mission planning, synchronization of spacecraft systems, and navigation in space, ensuring that missions proceed according to schedule. The development of optics and lenses by ancient Greeks and Arabs paved the way for modern telescopic and imaging technologies. These advancements allow us to observe distant galaxies, study celestial phenomena, and search for exoplanets, expanding our understanding of the universe. Alchemy, practiced by various ancient cultures, was an early form of experimental science. Although often associated with mysticism, alchemy contributed to the development of modern chemistry. Chemistry is essential for creating propulsion fuels, life support systems, and materials used in space exploration, ensuring that missions are safe and sustainable. Innovations like the Antikythera mechanism demonstrate an early understanding of gears and complex machinery, showcasing the ingenuity of ancient engineers. These principles are applied in the design of robotic systems that explore other planets, conduct scientific experiments, and perform maintenance tasks in space. Ancient techniques for mapping and cartography were essential for navigation and exploration. Civilizations like the Greeks and Chinese developed sophisticated mapping methods. These mapping techniques are crucial for planetary exploration, enabling precise navigation and the analysis of diverse terrains on other worlds. The philosophical and methodological approaches to understanding the natural world, as developed by ancient civilizations, are the precursors to the scientific method. The scientific method is the backbone of research and experimentation in all fields, including space science, driving our quest for knowledge and discovery. From ancient star charts to advanced space telescopes, the legacy of ancient technological discoveries continues to inspire and propel us forward. As we venture into the cosmos, we honor the ingenuity and curiosity of our ancestors, building upon their foundations to reach new heights. Join us on FTCWO as we explore the intersection of ancient wisdom and modern innovation, shaping the future of space exploration. Subscribe now and be part of this incredible journey.